Hello everyone, I'm Bradley Sward and this is my day 20 part 1 solution to Advent of Code 2024. The problem is called race condition. I'm solving it as always here in Python. So the problem is we have another 2D maze. We basically have one path through this giant maze, and at any point along the way, if we can cheat by basically moving 2 times through a wall, if we basically just shift through, like this is the point that gives us the biggest jump, because I can go right from here right to the end position and I can save all of that moving around, and that's what, 64 units or something like that. So for this problem they gave you a whole example of all the different cheats and how many different ways that, how many different picoseconds you could save. So the question was, for the data set you're given, how many could save you at least 100 units on the chart? So that's where we're starting from. And so for my problem, where did my data go? Where did my code go? Here's my code over here. And so the problem is as such. There's my answer. It agrees. So I'm just going through and I'm creating a 2D grid from the data. Basically trying to figure out what is the last square I'm supposed to go to, what is the square I'm starting from, and basically keeping track of all the squares that are dots or octothorpes. And so from there, the next part here is to say, now that I have that, let's generate the actual path that the character, the little person, moves on, the little winding path. So this basically goes through and does that, checks all 4 directions and makes sure we're heading in the correct direction. That's what this part here is for, because if it's already in the path, that's behind us and we don't need to continue on. So that's what this does. And then once I have the path, I basically have to say, for every step in my path, try each of these 8 different ways, because this is how, if I wanted to go two to the right, then 2 up, then 2 left, basically all the 8 different ways I could take 2 steps. Try it out, and basically if basically any of that stuff is on the grid, it's touching a dot square, and I save 100, add 1 to it. I mean, that's basically, for part 1 it's pretty simple. Part 2 is just going to be, I think we can brute force part 2. It's just going to take a long time to calculate the answer, but not a ridiculous number of lifetimes like other ones have here. So like this will get me the solution in a couple seconds here. I could simplify this a bit. I might have to for part 2, but we'll see. But I definitely get an answer of what we're expecting here. It just takes a little time. I could reduce this down to, maps and different things that are just not vectors. But for now, come on, let's get there. My solution will come up in a second here. Thanks for watching. Have a good one, everybody. I'm moving on to part 2. There it is.